Alright, this algebra lesson involves negative exponents. So basically we're going to look at how to rewrite negative exponents as positive exponents and then simplify as far as possible. In algebra, negative exponents need to be simplified. So that's kind of a general rule for simplification. If an answer has a negative exponent, it needs to be broken down further into positive exponents. That's what we're going to look at today. We're going to look at the powers of 2 and compare a little, see a little pattern here. So we're going to start with 2 to the 5th, which is 32, 2 to the 4th, which is 16, 2 to the 3rd, which is 8, 2 squared is 4, 2 to the 1st is 2, anything to the 0 power is 1. And then what I want you to look at is what happens when I do the opposite power. Sometimes you think that a negative power or exponent has to be a negative number, and that's not true. What you actually get is 1 over 2 to the 5th, which is 1 over 32. And that pattern is going to continue. If I continue this, 2 to the negative 4th is actually 1 over 16. 1 over 2 to the negative 3rd, so 1 over 8. 1 over 2 squared, so 1/4, and you can check that on your calculator. 2 to the negative 1 is 1/2. So there's a pattern here, and that pattern is that 2 to the 5th and 2 to the negative 5th are reciprocals, which means x to the n times x to the negative n always equals 1. And that's really important because we're going to rearrange some expressions to take away negative exponents, and we don't want to completely change the expression itself. So the negative exponent property then says this, that b to the negative n is the same thing as 1 over b to the n. Same expression, except it's being rearranged. So, if we take a look at this first example, a to the 7th doesn't change, but according to the property, b to the negative 4th is 1 over b to the 4th. We never want to leave this with a multiplication symbol right here. We want to put that into one fraction. So I'm going to write a to the 7th over b to the 4th. And that's my final answer. Same thing down here. This should be positive. C to the negative 8 times d squared would be 1 over c to the 8th times d squared. Nothing changes with that. And then we want to put that into one fraction. So the d squared is the numerator. C to the 8th is in the denominator. So those are a couple of pretty basic examples showing you how to rewrite a negative exponent as a positive. What happens is it always just goes into the denominator as the positive exponent. But now what if b in the property above would be a fraction? Then we're going to use the negative exponent property. And basically the negative exponent property says that if you have a fraction x to the y, x over y to the negative n, you flip the fraction, you take the reciprocal, and keep or make the power positive. So x over y to the negative n is y over x to the n. Let's apply that to an example with just numbers. So 5 over 4 to the negative 2 power would be 4 over 5 squared. And at this point, that's the only property we can use, but we could take each of these separately, and I could do 4 squared, which is 16, and 5 squared, which is 25. That's another exponent property in a different presentation, but for now, we'll just leave it at 4/5 to the 2nd power. What if I have variables? Well, I would write m squared over 1 to the 3rd, and then what happens with this? It's the same thing as m squared to the 3rd, and then that's another exponent property that you've maybe learned already, and that's power of a power, so which means you multiply these. So your best answer for this is m to the 6th power. So that's what you do when you have a base to a negative power. We can apply this to a word problem. Let's take a look at example 3. It says 10 years ago, Don put money into a college savings account at an annual yield of 6%. It's now worth $9,491.49. So we can find out the initial money invested by using this key sequence, which is really the same as if you were looking into the future to see what the amount would be if you want to go backwards. The only difference is you have this scale, 1.06, because it's 6%, and you have to use a negative 10 to go backwards. And when I plug this in, I should get a smaller number. So I know that, put that down here, about 5,300 was invested at the beginning. And then after growing for 6%, it basically got us to $9,491.49 after 10 years. Let's take a look at this example at the bottom here, 8a, and then you can maybe try the other one on your own. What if I have a fraction with numbers and variables to different powers? Well, you know from previous properties that you have to reduce the numbers. So 5 over 15 is going to be 1/3. And then you have 4 minus 11. You always subtract the powers down. And so that's a to the negative 7. 7 minus 5 for the b's. 2 minus 3 for the c's. And you're left with this right here. Now, as I said at the very beginning, we don't want negative exponents, so I'm going to rewrite this as b squared. That's the only thing in the numerator, along with the 1, but we don't need to write that. That's all divided by 3a to the 7th c. Because our negative exponent property says negative 7 in the numerator becomes 7 in the denominator. This was c to the 1st. And so my final answer is this right here, b squared over 3a to the 7th c. So that's one of the examples. Maybe try the other one and see if you can get something that checks. To check these, you plug in numbers for, in this case, a, b, and c in the original, and then check it with the final answer. And then you'll know you have an equivalent expression. That's it. Thanks for watching.